All right. Hey, everyone. If you're just joining us, welcome to our Customer Perspective webinar today on nailing ELK at scale. We have Holler joining us today, but just some quick housekeeping items before we begin. So first, this will all be recorded. So if you need to get up for a moment, you can always rewatch what you may have missed. And second, feel free to ask any questions you may have in the question box. We're going to leave some time at the end for Q&A to get all your questions answered. So now I'll turn it over to Daniel, a lead engineer over at Holler. He's going to tell us about his story, or his team story, scaling ELK, and then the transition to Logz.io. So Daniel, take it away.
Thank you, Charlie. And thanks to the rest of the Logz.io team, Jeff, everyone else, for inviting me today to talk a little about Holler and our partnership with Logz.io. I'm very excited to be here, and hello to the audience. Thank you as well for joining me today. I'm a lead engineer at Holler, and I mostly work on cloud APIs, infrastructure, and DevOps, which is what led me into the relationship with Logz.io. I think early last year is when we started. So let's dive right in. A little about Holler first. We're a messaging technology company, and we produce and deliver original stickers to a network of partner applications. We distribute iOS and Android SDKs to a bunch of different applications around the world. And our goal is to operate wherever conversations are happening. Today, you can find us in places like Venmo, iMessage, and Kika Keyboard. So if you've recently used a sticker in Venmo and that panel has popped up, that's us. And the primary feature of our SDK is to provide contextual matching against message text to deliver the most relevant stickers to the user. And there's also a search interface in there that people can use to browse the catalog. So as a company, there's really two things we try to nail. It's the quality of our content and the quality of our content recommendations. So we have an in-house animation studio that produces all of the stickers. And at this point, we have a pretty big library of original characters. They follow an editorial calendar. It's a constantly updating library, and it's all done in-house by a team of very talented artists and animators. The second thing is the data side of the equation, and we have a research and data team that is constantly exploring the state of the art in natural language understanding and processing algorithms to improve our recommender logic. And while most of that sticker content is what we call Holler originals, just the the animations and the characters that the studio team decides they want to make, a portion of it is created by our team in partnership with brands. And here's some of the brands around the world that we've worked with to date. And we've worked with a lot of great brands so far, and we help them translate their brand identity into sticker packs that work well in this new medium. A lot of times a brand will just say, we want our logo to be a sticker. And there's always this process of telling them, people don't want to send each other logos. They want to send each other, fun stickers. And this animation on the screen, I think, is a really good example of what we did with Subway. So this is a Venmo interface where Subway owned the keyword sub and sandwich and other relevant ones for a few weeks. And when people typed in those keywords, they would see the 3 branded stickers. And these are all real, by the way. This was a real Subway campaign we ran earlier this year. So with that advertising model, the brands basically get the option of owning a topic, a mood, or an intent. So this goes back to, we're always trying to understand the context and the real meat of what people are typing, and pull out these 3 different attributes and allow brands to own those 3 different things: mood, intent, and topic. And today we are touching over 1 billion messages globally every day and growing. So that's a little bit about our company and what we do. Now getting into the technology and what we use Logz.io for and how that partnership works for us. So we have a pretty robust event ingest at Holler. Our network of partner devices is in the tens of millions and growing these days. So, and every time a user on one of those applications is viewing or sharing one of our stickers, we get just an event of that happening. So we can do different things with it. So we have an events API that receives those events that goes into a Kafka queue, and there's multiple consumers and systems running off that Kafka queue. The three big ones are the business intelligence pipeline, the campaign management system, and then the data science team has a core data lake they use to read off of, to do science off of those events rather. So each of these systems generate logs and metrics. So we have the load balancers in front of the API servers themselves, Kafka, and all the consumer services are generating metrics and logs. So it ends up being a lot of data. And that's just the logging data. Of course, the actual event data itself is pretty massive per day, and that's all ending up in Redshift tables that are consumed by the BI pipeline. And then we have dashboards that are running the campaign management side of thing, and by campaign I mean ad campaign. So it's a CPM model, so we have to track impressions. We hook into third-party attribution systems that a lot of the big brands like to use, such as Nielsen, so they can verify our traffic. So that's kind of why we have so many logs. It's just all these different systems in this event pipeline. So to wrangle that, we, like a lot of companies, chose the ELK Stack, Elastic, Logstash, and Kibana, the same stack that Logz.io is built on, of course. We started in the beginning with a self-hosted ELK Stack, and it worked well. I mean, we chose it because it's well-supported open source software. We had experience with Elasticsearch, which we use to back our search APIs. And in the beginning, ELK's very easy to get started. But as our traffic scaled and things got crazier, we had a lot of trouble keeping up with that. At this point, I'll note we don't currently have in-house operations. So we have a very lean back-end engineering team of 5 or 6 these days. And we are currently hiring a few DevOps positions that I'll mention later. But for the last year and a half, 2 years, where we've really experienced a lot of growth, we haven't had in-house operations. So it's people like me, doing double duty on product engineering and ops. So we just didn't keep up with scaling ELK. One thing to note here that's interesting about our business is because all of our traffic comes from SDKs that we've from companies that we partner with that are using our SDKs, our traffic kind of grows in a step function. So it'll be pretty constant for a while, and then we'll bring on a new partner, and then over the course of weeks, our traffic goes up by whatever their user count is. So we don't have like a smooth traffic pattern, and we don't always know, unfortunately, when we're going to get a lot of new traffic. Like we've had existing partners that will launch us in a new app that we don't necessarily even know about, and all of a sudden, we're ingesting a lot more events. So things like that got us in a situation where our ELK stack just wasn't working. Kibana queries took forever, and it just wasn't usable. And that hurt us the most when things went wrong in our data pipeline. We really needed that data to figure out what's going on. Of course, that led to a really long time to resolution of issues, which in our case usually is costing us a lot of money. We've had quite a few cases where there will be a bug in an SDK that is pretty hard to catch in testing, but it shows itself at scale, and a partner will update their SDK version, and all of a sudden we're getting too much data than we'd expect, so the data profile gets away from us, and of course we're paying for every step of the journey that data makes through our pipeline and compute and S3 at the end. So it's really important for us to spot issues with this data pipeline and fix them quickly. And honestly, in the early days, ELK was just a dumping ground and a strategic piece of our infrastructure. It was kind of default that when we had a server with some logs on it, we just throw FileBeat on it and stuff would get shipped over there. But there wasn't strategy around structuring these logs or parsing them or really thinking through when and where and what to log from our infrastructure. So it was all that led us to Logz.io. We knew we needed to do log aggregation, and we knew we needed a strategy around logging. So we started looking at different providers, and Logz.io stuck out immediately because it was ELK. We wanted to stay with ELK because we're big believers in sticking with open source when we can, and Logz.io's model of running open source software for us is one we really like. It's something we also do in our Amazon Web Services account, where given three options of running something ourselves, going with a proprietary technology, or going somewhere in the middle where it's a open source technology but we're not running it, we tend to go for that middle option as much as we can. And again, we had some Kibana experience, so it made sense for the team to stick with the tool they knew on the front of the stack. But for us, it was more than just someone to run the cluster for us. Like I said, we didn't have a lot of strategy around logging. So the fact that Logz.io can come in and help us with consulting and just support of the stack, things like not having to write our own parsers, where we can just call up our support rep or send them a Slack message and say, hey, we have this new system. These logs are kind of a mess. Can you help us structure them? What should we parse out? Things like that have been super helpful. It's just more and more hours of stuff that we're not doing, so that our engineers can then use to focus on product, which we definitely want to do more of. The other big thing with us with Logz.io is unified logs and metrics. I haven't talked about metrics yet much, but we really didn't do a lot in the way of metrics either prior to Logz.io. It was a lot of, basically, if CloudWatch gave it to us for free, that's what we had. So with Logz.io, it was a big selling point to say, well, not only are you getting ELK, but you're getting Grafana, and we can help you figure all that out as well. And over the past year or so of working with Logz.io, they've proven themselves time and time again to really know these technologies, and it helped us many times in working with them. And the last thing I'll say is the flexible commercial partnership has been really helpful for us as well, in terms of, like I said, it's hard for us to predict our traffic over time, which also means it's hard for us to predict how much log data we're going to be generating. And for those of you who don't know, Logz.io's logging billing models is based on data ingest, essentially how many gigabytes you send them, and retention. So generally we can figure out, how much are we going to send 6 or 12 months from now, but it's a little trickier to say how long it's going to take to get there, because it's really dependent on our partners and not just us. And Logz.io works with us and letting us back into a contract over time and ramping up how much we're paying for the ingest as we need it. So that's been very helpful. All right, so now a couple examples of what we're actually doing with Logz.io. First is a screenshot of one of my Grafana dashboards. And this is for a Kafka cluster. And I like this one as an example because it's kind of a amalgamation of all the things I've been mentioning that made this happen. So first of all, having Grafana up and just knowing that we can toss, if I add another Kafka cluster with 30 brokers and I start shipping it over, I know it's just going to work. I don't have to worry about, okay, do I have to go scale Elasticsearch or Prometheus or Grafana or whatever it is. But it's more than that. Just thinking through Kafka metrics, the Logz.io team is very helpful in informing us, well, these are the types of things you should be looking at from a Kafka cluster. Kafka exposes a ton of time series metrics from its JMX exporter, and most of them are just noise, in my opinion. And it was just a phone call away to say, hey, Logz.io, which of these 1,000 metrics actually matter? They told us that, and then told us, well, here's our recommended way of actually pulling those JMX metrics out of your Kafka brokers and then shipping them over to Logz.io. So we're talking something that would have probably taken me days of effort to learn about and figure out and piece together, was pretty easy to get going, because again, just having that team to call upon, super useful. And the next example, I wanted to show a picture for this, but it was a little too hard to scrub it of a proprietary data show. So unfortunately, I'll just have to explain it. Shout out to Zach on this one, who's one of our support engineers at Logz.io. He helped me set up a cool solution where we are able to sample our AWS application load balancer logs. As you can imagine, we generate a ton of logs into our access log S3 bucket. It's many billions of requests per day. And it makes no sense to ingest all of those into Logz.io. We'd be paying a ton for the ingest, because I don't even know, it'd be hundreds and hundreds of gigabytes a day of just wasted space that we're not going to look at. So what we did instead is came to a solution in partnership with the team over there to ship just 1% of those logs into Logz.io. The way it works is described here on the screen. It's basically just a Lambda function that's triggered on an S3 event. That Lambda function reads in the file, grabs 1% randomly of the entries in that file, and then uses the Logz.io HTTP API to send them over. And every step of the way, and there's a pretty cool Kibana dashboard that backs this. It tells us things like, you know, where's our traffic coming from geographically, real easily. How does it split up among our key dimensions, which for us is like partner application ID, locale and language, and then what version of our kit we're running. We encode all that data into a few of the key API routes, so they're present there in the access logs. And some of you may be thinking, well, this sounds like something they should be doing in their data pipeline, and that's true. But you know, when there's a lot to do, it's great to have a quick solution that's pretty much just piecing together a bunch of out-of-the-box technology to kind of get us the same or similar level of insight on our traffic volume without having to do it in the data pipeline. And the great thing is the data pipeline is broken. This sits in front of all that. It's right at the load balancer level. So it's completely run by managed services in terms of AWS load balancers and Logz.io systems. So our entire thing can be down and we'll still be getting, you know, this traffic data out of this Kibana dashboard. And again, it's something that would have probably taken, I don't know, a couple weeks maybe to do without Logz.io, and just having a team of people to call on there with so much experience was just really awesome. Moving forward, we expect this partnership to be even more fruitful. So right now we're using the ELK Stack and Grafana. And soon there's a beta we're a part of that will throw Jaeger distributed tracing into the mix for us, which is timed great for us. We're doing more and more of our new cloud APIs with a microservices architecture on Kubernetes. So distributed trace is about to get a lot more important for us than it's ever been. And we're excited to, again, not have to run all that Jaeger stuff. We can just run the agents, collect the traces from our different microservices, ship that over to Logz.io, and just more and more hours we're saving on operational stuff. The other things we're excited about is learning more how to connect our data across the 3 products. It's a feature set that I know Logz.io has, but we've only used it a little, just kind of saying, oh, here's a metric, click on the timestamp, go see the log entry. But another big benefit of what Logz.io is doing is integrating these products together into one suite and adding, while it's still open source at the core, there's this layer of additional functionality on top that we've used a little in the past and are excited to use more in the future. So last thing I'll say is we are hiring currently at Holler 3 key engineering positions, an SRE and 2 software engineers to work on the back end. Feel free to check out our careers page, check us out on LinkedIn, or just email me directly. Thank you. Any questions?
Cool. Thanks so much, Daniel. Great story to hear about. Make sure we have a few questions already. Make sure if you have any that you haven't asked yet, make sure to put them in the chat box down below so that we can get them answered here. So the first one I have is about log shipping, Daniel. We have a question about the method you're using to get your log data from your load balancers and from your SDKs over into the Logz.io platform.
All right, so first is we don't ship any logs directly from the SDKs. We try very hard to ensure, and it's true still to this day, that the only HTTP requests coming from our SDKs are to our infrastructure, because our partners, you know, they don't want us sending data to different places. It's just a conversation we don't want to have over and over again about, you know, why are you sending data here? So all log shipping is done from our back end. So in terms of load balancers, in AWS, you can just turn on access logging for any application load balancer, and you just configure it and point it at an S3 bucket, and then it'll start just putting your logs in there automatically. I forget the name of the format that it's in, but it's in like a standard like server format that Logz.io already knows how to parse. The way we're shipping them over is there's a Lambda function that is configured to trigger itself anytime a new file is written to that bucket. And these files are batched up, so that they might be like 20 or 30 megabytes each. So it's not like one event per file. And then I just, in that Lambda function, I download the file into the Lambda's memory and just sample 1% of the entries within that file, put it up into a batch, and then use the HTTP API that Logz.io provides to just send it over. And then on the Logz.io side, they automatically do geo enrichment and parsing of that log type. And in this case, I didn't even build the dashboards. Zach again built all the initial dashboards, but I didn't mention this. What's super cool is once we had that initial dashboard and my team saw it, they went and built, custom dashboards to their needs. So it's been really interesting to see the team use Kibana like that. More generally, for shipping logs from other services, we have some older servers that are still dumping logs to a file, and we're using FileBeat for that. In Kubernetes, there's a shipper that Logz.io provides, and when you just shoot your Kubernetes pod logs over to standard out, it's picking them out and shipping them over, and it's all automatically tagged with all the different the pod name, the cluster name, all the different dimensions in Kubernetes. And then we're using MetricBeat globally for metrics. Again, Logz.io has pre-built containers to do that in Kubernetes. And then we also use Telegraph, which is a different metric shipper. And I use that in the Kafka clusters because it has a really good integration with the way that Kafka exposes metrics, which is through a Java thing called JMX.
Cool, thanks, Daniel. A follow-up question on that one. How much bandwidth does your log shipping take approximately?
I couldn't tell you, and I count that as a good thing because it's not something that concerns us, right? It's in terms of the amount of data transfer we're doing in general out of AWS, it's a blip on the chart, so it's not something we've even monitored, to be honest. Sorry.
Makes sense. That's good to hear. If you could go back to your Grafana slide, your slide with your Grafana dashboards, there's a question if the metrics displayed there are from CloudWatch.
I'm circling back to the last question. What I can tell you is we ingest about 150 gigabytes per day into Logz.io, but that's not equal to bandwidth because that's the post, uncompressed once it's turned into a JSON index for Elasticsearch. So the actual bandwidth coming out of our infrastructure is going to be smaller than that, but by how much, I don't know. On Grafana, for the Grafana dashboard I showed was for one of our prod Kafka clusters, and no, there's nothing from CloudWatch populating that. So what's populating that is MetricBeat on the Kafka brokers, which is picking up system level metrics, CPU, RAM, network, stuff like that, and then that Telegraph shipper that I mentioned. So a little more detail on that. Kafka and a lot of Java apps, as I understand it, expose metrics on this JMX protocol. There's something called Jalokia, which you bind to your Java process, which then exposes those metrics on an HTTP endpoint. And then Telegraph, which is a metric shipper, has a Jalokia input plugin. So you just point it at that endpoint. You tell which metrics you actually want to pull out of it, because again, there's a ton of them. And then as an output, I just send it over to Logz.io.
Cool, thanks, Daniel. Next one is about your selection process when you're deciding, when you were, once you kind of realized ELK Stack maybe didn't have the manpower to handle scale ELK Stack on your own. When you're evaluating other vendors, I wonder if you can walk us through that selection process a little bit. If you were comparing Logz.io to proprietary tools, what were some of the pros and cons?
Yeah, certainly. So we did look at some of the the big names in proprietary metric and log aggregation, but again we lean heavily open source. So it was compelling to us that we can take the knowledge we already have about ELK, still use it within the things that Logz.io will host for us, And if there's a future where we need to run our own infrastructure, it's not going to be a big shift in terms of what our team knows how to use and all the dashboards. So it's portable. It's data portability is a big thing for us. Supporting open source has gone very well for us and a lot of companies, obviously. So and there's also a cost factor there. At our scale, just like I remember looking at a New Relic or something where it's a per node pricing model, and it just didn't make any sense for us. We're kind of a weird startup where we're still a startup. We're between Series A and B right now, but the amount of data and users we're supporting is mind-boggling just for our size. So we kind of have to be careful with cost, very careful. And also just the team was very easy to work with in the early days of the conversation. I remember being on these early calls with our account executive, Bill, and I kind of couldn't answer any of his questions because we just knew so little about our logging needs and where things were going. And it was a good process of them helping us figure all that out and arrive at a contract that made sense.
Cool, thanks, Daniel. Looks like that was it for our questions, unless there are any other lingering ones. So thanks so much. It was really helpful hearing your story. Really cool hearing about your elk journey. And yeah, looks like that's it for today. So Daniel, thanks so much for joining us today and telling us a little bit about your experience with ELK and Logz.io.
Yeah, thanks again, Charlie, and thanks to everyone on the line. I hope you found it informative. Take care.
All right, bye everyone. Thanks again for joining.